Good day, everyone, and welcome back. This is Pre-Calculus Algebra 2 with Mr. Malcolm and Mr. Taylor. I hope and trust that you guys had a good day yesterday, and that today, with no exception, will be even better. Um, Here on the screen, you can see the Think About It section for Lesson 9.03, Trigonometric Ratios, for April 22nd, 2020. Please make sure that you, at this time, have your notebook out and you have your heading up and you put in the correct date and everything is good to go. Um, Now, please take the next 5 minutes to try the problem on your own, and then I'll return to the video after you are finished, and we will work through this problem together. All right, so pause the video at this time. All right, welcome back. Hopefully you were able to work through this problem and use my diagram here as a guide to help you to get through it. So let me get through showing you exactly how this lesson is going to take place, all the little details that may seem confusing to you. All right, so let's start with the first thing, which is reading the question. The question says, you are familiar with three trig ratio: sine, cosine, and tangent. You have also used inverse trig functions as inverse of sine, inverse of cosine, and inverse of tan. The inverse trig functions also have special names and relationships defined below. Use these definitions to evaluate 6 different trig functions, or trig ratios, for theta, or angle theta, equals pi over 4, and the diagram given to the right, or in this case, below, since I'm reading from my slides. The first thing we need to do is to understand how they end up with this 45-degree angle. The diagram at the right showed you the 45 out of nowhere, so I went ahead to show you how we got that number. In order to get that number, you have to change this pi over 4, which is in radians, to degrees. I went ahead and did the math for you, and here we are, 45 degrees. And this is from earlier this week, where we learned how to change from radians to degrees. Okay? Now, the second thing is to figure out how they ended up in the diagram finding the x and the y values being root 2 over 2 for each one. Now, if you remember from yesterday's lesson, in order to find the value of the sides, what you use is a special triangle theory that we learned earlier in unit 8. This one is a 45, 45, 90. Since we found out that this angle is 45, this one also must be 45. So, or 45, 45, 90, and we know x for 45, x for 45, and for the 90 side, or the hypotenuse side, it should be x root 2. So we set up a simple algebraic expression to say what value times root 2 is equal to 1. And that value is 1 over root 2. So that would mean that for both of the sides, it should be 1 over root 2 apiece. Now, the third thing is, how do you go from 1 over root 2 to being 2 over 2? Now, in math, it's always better to put the root, or to not have a square root in the denominator. So to fix that problem, you can multiply 1 over root 2 by 1, or in this case, root 2 over 2. When you do that, you won't mess with the value at all. It will just be writing the same thing in a different way, just getting rid of the root in the bottom and putting it in the numerator instead of the denominator. Okay, so when you do this, you end up with 1 times root 2, which is root 2, and then root 2 times root 2 is the same as 2. Okay, that's how we end up with root 2 over 2. Just wanted to clear up that, just in case you had questions about that, how they end up doing it. It was not really explained because of the earlier lessons this week. They expect you to build on what you already know. So I just wanted to review that quickly. Now for the actual things today, we're asked to find sine of root of pi over 4. Okay, or same as sine of 45 degrees. Either one will give you the same answer. Okay, so in order to do this, what we would need to know is sine as a function says opposite over hypotenuse. From unit 8, we learned that it is from SOHCAHTOA, opposite over adjacent. The opposite side to the 45 degrees in question here would be the y value. Okay, so it should be opposite over adjacent over the hypotenuse, and the hypotenuse in this case is 1. So the value of y is root 2 over 2 over 1, which is the same as saying root 2 over 2. Okay? Now, for a little shortcut, whenever you're finding the sine of any one of these, it is going to be the same as the y value. So whatever the y value is, that's what the answer is going to end up being, because as you can see here, it's always going to be over 1, since all of these will have the values from the unit circle, which states that from the center to the edge is going to be 1 unit, since it's called the unit circle. So all of the radii are going to have 1 unit. So the sine will just be the y value. Similarly, with the cosine is just going to end up being the x value, because cosine we have adjacent over hypotenuse. Adjacent here is the x over hypotenuse 1. So we have root 2 over 2 over 1, which is the same as root 2 over 2. Okay, so this is how we know that sine is going to give you the y value, and cosine is just going to give you the x value. Okay, now for the tangent is going to be opposite over adjacent. So y over x. Okay, so the y value is root 2 over 2 over root 2 over 2, which is the x value. What happens, or how can you do this? Let's make this a little bit better looking. We can say root 2 over 2 divided by root 2 over 2, which is the same as saying KFC, keep it, flip it, or yeah, keep it, switch it, flip it, whatever the saying is. Okay, you change it to multiply, and then you have 2 over root 2. When you put these together, this cancels with this cancels with this. So all that we're left with is 1 over 1. Okay, listen to this one time. Listen to yourself one, to that one. Okay, so all you're left with is 1 over 1. I'm just going to give you 1. Okay, hopefully that's clear. The cosecant is going to be the inverse of sine. So in other words, you take this number and you turn it upside down. So if you turn this number upside down, you'll end up with root 2 over 2. Oh, 2 over root 2. Sorry. Okay. Now, remember from example, from the third thing that we discussed, that we don't want to have square root in the bottom, so we can change this to become, we can just multiply it by root 2 over 2, or 1, in order to get rid of the root in the denominator. When we do this, we have 2 root 2 over root 2 times root 2 is 2. Now we can further break this down to have this. These two numbers cancel. And then we end up with just root 2. Okay. The secant is the inverse of the cosine. So flipping this number again, we end up with the same thing. So to avoid doing all that work, we know it's going to be the same thing as before, which is just going to be root 2. Okay. Now, the cotangent is going to be the inverse of 1. So it's going to be 1 over 1, which is the same as 1. Okay. Now, hopefully, this was helpful for you. Let me go ahead and emphasize my answers. Okay. All right. Hopefully, this was helpful for you, and it has cleared up all your misconceptions, and that you'll now be proficient and have mastered the rest of this lesson. The rest of this lesson is using the same concept to get all 6. Note well that when you're doing the required problems, make sure that you note which one of these I'm asking for. So you'll see that I asked for the cosecant, the secant, and the cotangent of questions 1, 2, 3. Make sure you know which one that I'm asking for, and you don't have to put in the answers for all of them. I'm just looking for specific ones. Okay? All right. I'll see you in class. Have yourselves a great day. Bye-bye.